Welcome to Broad Eye, the podcast that explores knowledge gaps in ophthalmology and eye care. Hello, everyone, and welcome to another episode of the Broad Eye podcast. My name is Sean Maloney, and I'm here today with my co-host, Dr. Bruno Fernandez. Bruno, welcome.
How's it going, Sean?
I'm doing all right. I'm pretty excited about our guest here today. We have Mr. Andre Larente, who is the president of Diagnose. So, Andre, welcome to the show.
Thank you, Sean. Hi, nice to meet you there, Bruno.
Nice to meet you too, Andre.
So, I was hoping, Andre, we could start off with a brief history of Diagnose. What is the company? How did it start? What is it doing today?
Sure. So Diagnose started in 2001. So we're a fairly old company. And our objective in 2001 was to actually build a AI platform. In those days, it wasn't called artificial intelligence. It was called machine learning language. So this was a platform to actually analyze large data sets, medical data sets, and apply some of the intelligence to some of the pathologies in terms of trying to identify them in the early stage. And at the beginning, we started with breast cancer. So we were actually analyzing mammograms. And then it was very clear that the medical field was not ready for this kind of application. They felt very threatened by the AI, if you want. And so we went to other fields. So we did FX, so foreign exchange predictions. We did also a music application where we could predict if you had a potential hit song on your hand for amateur composers. We did, then we went into a mining area where we're actually analyzing very specific geophysical data. So very, very technical things to help mining geologists to actually find gold, silver, copper, whatever they were looking for in terms of mining assets. And then 7 years ago, I was at the Université des Mines in Paris, and we were looking at an algorithm to actually detect oil and gas. And one of the students barged into the meeting and actually told the professor that we were talking to that they just had a grant to analyze retina images. So this goes back 7 years ago. So we had a very long discussions about retina. And it was so weird because if you look at a geophysical survey, the output, and you look at a retina, it's almost identical in terms of color, shapes, and things that you're looking inside the image. That has a very significant impact. So we came back on the plane. I changed some of the architecture of my platform, and we started analyzing retina images 7 years ago. So that's how we started.
That's very interesting. Can you just give a very brief overview of how the technology works for like the non-tech person? How does it work, and how is it able to make a diagnosis?
Sure. So artificial intelligence is a big buzzword, and a lot of people have used the term. But the way it works essentially is if you're going to start tackling a problem that's very sophisticated, AI is not good to do reporting and small tasks. It's much better when you have very complex things to analyze. So the way it works in our field, so we've actually analyzed over 250,000 patients' retina. So 500,000 retina, if you want, 500,000 eyes. And in these retina, there was different pathology. So the identification or the grading of the severity of the pathology was done by ophthalmologists, retina specialists, and to some degree, some optometrists. Once you have a very large database of significant events like this in the different pathology, then you can actually now train the algorithms to identify what you're looking for. So an example, microaneurysms. So once we actually show the algorithms maybe like 2,000 or 3,000 images that has microaneurysms, the technology starts to recognize the microaneurysm. You want to look at exudates, then we train the algorithms to look at an exudate. If you're looking at a cotton wool spot, then we train it like that. We also train it to look at bleeding, so blood vessels that bleed. So we train the algorithms based on thousands and thousands of examples. And the output at the end of this, once the algorithm is trained properly, we now do clinical tests to make sure that you have the right specificity and sensitivity. Those are technical terms for the medical field. It means that once we analyze a new picture or a new retina of a new patient, well, the results have to be over 90% in terms of specificity and sensitivity, meaning in a normal jargon is that the algorithms can do the same analysis as an ophthalmologist or retina specialist can do.
Okay, so that's. Sorry, go ahead, Bruno.
Yeah, no, just a follow-up question to that. So in reality, what the machine does is basically get better with every diagnose it makes, right?
Actually, it doesn't really work that way. This is kind of kind of a marketing thing for AI. Actually, AI, it's I would say has to be retrained. The algorithms have to be retrained. So what we do here, we retrain the engine to look at data every 6 months. So it's not something that goes on every field. Nobody really works that way. So it's supervised training, if you want. So we actually, the more data we have, so we reapply the training every 6 months on the specific pathologies that we're doing.
Okay, got it. Yeah, no, that's clear. Thank you.
Yeah.
So, okay. So now you're getting these fundus images, I guess, from patients. Clinicians are supplying these images, giving their diagnoses, and then you're using this information to train your algorithms. I have a few questions on this, but is it the clinicians that are ultimately going to use this technology, or is the idea to eliminate the clinician, that they don't have to make the diagnosis?
So there's no elimination of anybody. You guys studied in ophthalmology, so looking at a retina is a very difficult and very difficult from a human being perspective. If you look at these images all day, you're definitely going to go crazy. So the idea here is was to develop the platform to help nurses, doctors, opticians, optometrists, to actually do the first line of screening, and even also endocrinologists. Now, we started with diabetics because it's a huge market and there's a big problem. So we position our technology at the primary care facility or inside an endocrinology department or inside an optometrist clinic or store. And the reason why we do this is to actually triage the patients and send the patients that need to be referred to the ophthalmologist. If all of that was done today, there would be enough ophthalmologists to take care of the sick. Today, there's not enough because a lot of times referrals are sent to the ophthalmologist that should not be there. And so that's where we position ourselves to help doctors, nurses, optometrists, opticians to actually do the screening for the ophthalmologist.
I can imagine that that you're also standardizing some of these staging and diagnoses as well, right? So if across from one center to the next, or from using the same ophthalmologist one day to the next, there could be some variability, whereas what you're providing can actually be used for standardization. So can this be used for let's say clinical studies to be able to standardize across centers as well?
Well, look, you touched the right button here. I mean, the idea that we have is to standardize the way the first analysis is done. You show a retina picture to 10 different ophthalmologists or 10 different retina specialists. None of them will have the same verdict, except for the things that are easy to find, So it's very subjective. So what we're trying to do is to put objectivity into the screening, where we actually have the same base for everybody. And once the identification is done, then the referral to the specialist is very, very much faster. So there's a lot of cost savings by doing this, cost savings in time and all that. We actually have a clinical trial at the CHUM here in Montreal. So it's as you know, it's a very brand new hospital, it's very sophisticated. And we actually are doing it. We're working in the endocrinology department with the ophthalmology department. So Dr. Laoud and Dr. Boucher. And what we have proven in the last 12 months is that we can reduce the waiting time for the patients that are really sick instead of sending people that are not sick. Number two, the ophthalmologist, when he gets a referral from us, has already a basis from the fundus camera. Although they all want to do OCT images, it's very nice to have a first glance of the patients that's very clear. So, you know, there's retinopathy, there's this, there's that, and we actually do the classification with the AAO classification or grading sheets. So we have R0 to R4, R4 being critical, R0, you have nothing, and for maculopathy and also for macular edema. So when the referral is done, it's very fast. So the standardization is now a real process out there. After, you know, working in this field for 7 years, I would say the last 2 years have been very good. We've done very large clinical trials, all the way up to 150,000 patients. So, so now we have developed the proper solution for the proper primary care facilities and also optometry world to do that basic classification that's required.
That's very interesting. So it seems that the company technology is very focused on diabetic retinopathy for now, and I understand the reasons for that. It's a very prevalent disease, so it's easy to get numbers, and it's also very visual. So the technology like fits like a glove. But the whole field of ophthalmology, it's pretty much like very similar, right? Like, I mean, we work on images for pretty much everything. So do you see what's next? Like, I mean, that's the simple question there. Like, I mean, what's the next ocular disease that the company is interested on getting involved on?
Right. So, so number one, we have adapted the platform for optometrists. So it's no longer just for diabetic retinopathy, but just retinopathy. So that could be a pre-test for everybody out there. In terms of development, we have several applications that will be delivered in the next 12 to 18 months. So the first one will be an application where we actually monitor the state of the arteries and veins inside the retina. So once you can see the microcirculation from the retina, you can now apply this to other types of diseases, such as if you suffer from hypertension, so you can develop hypertensive retinopathy. So now it's good for hypertensive persons. We also have we've announced a couple of weeks ago, a new app to actually predict a stroke. So through the analysis of the blood vessels in the retina and other things that we look inside the retina, we can actually predict that you're gonna have a stroke and also a heart attack. And we're going to be announcing in the next few weeks a clinical trial in the US with the second largest hospital operator. And so that's in the process right now. Most likely the SHUM will participate in the clinical trial for this. So we have hypertensive, and hypertension review. We'll have a stroke predictor. We are working on a glaucoma and AMD specific program here. Glaucoma was not something that was really required up to now, but now there seems to be a demand out there. So we have the technical papers already done 4 or 5 years ago on glaucoma. So we're now just going to finish glaucoma and that. We also have a special program that we're working with Bascom Palmer in Miami. So are you aware of Bascom Palmer?
Yeah, yeah.
Okay, so we've been working with them for 7 years. Actually developing a new application. We're going to be using the OCT analysis to actually confirm the fundus image where there's macular edema. And the reason why we're working on this is that there's thousands and thousands of fundus camera out there, and the new fashion for ophthalmologists is to run these OCT images to confirm, you know, the edema is right there, and then you can actually inject medication in the right area. So we're going to use the OCT technology to actually increase the effectiveness of the fundus imaging. So this is something we've been working with them for the last 5 years, and we're very, very close of having a success with this. It's going to be very interesting. So, and indirectly, we'll be also be able to analyze OCT images automatically using AI.
So we're diving into a lot of things in ophthalmology, and that's obviously where your focus is. And but I can't help but think of implications of this, right? So I think, as you know, my background is ophthalmology, but also pathology, and we saw a lot of patient samples and back in our research days, both Bruno and I. And could you not use the same approach, the software you're using to, or that same idea to analyze, biopsy samples, looking at slides and trying to look at, for example, tumor cells or, structural changes in specific tissues to aid in diagnosis as well?
Yes, absolutely. It's just a question of time and effort and people and money. So right now we have our first application in production. So for retinopathy, we'll have a second one very soon that monitors patients that are hypertensive. We will have another one that actually can predict a stroke. We've done work in breast cancer, as you know. We've done work also in analyzing pneumonia, so CT scans. There's a lot of things that can be done. The neat thing about our platform, it is an open platform, and we can actually bring in images from different types of things. But remember one thing, anytime you get into a development, we need to have access to data. In Canada is not a good place to having access to data. Most hospitals and governments, provincial governments, do not give you access to this data. This compared to other countries where they actually give all the data out, such as Korea, China, and other places where they will provide, millions of images free to the industry so we can analyze it.
Sorry, Bruno, I'm going to let you. I was going to jump into a question about the future of AI, but maybe you want to take that one. I think this is more your domain.
Yeah. It's as I said in the beginning, AI, it's a very buzzword nowadays. People tout that as a solution for pretty much everything. Some people embrace that as the cure for all. Some others are scared that they're gonna have their jobs replaced. Specifically for the field of ophthalmology, how do you see AI impacting such field in the coming 5-10 years?
Yeah, so I worked, I worked in many countries. We worked with top-notch, Neil Bressler in the U.S., top retina specialist, Jason Slachter, who was a very senior ophthalmologist also in New York, and a lot of other associations worldwide. I think that today the ophthalmologists are a little bit less scared of what we do because they can now see the benefit. I mean, we're not there to sell this technology to the ophthalmologists and the retina specialists. We're here to make sure that whoever is referred to them is a good referral because their time is limited. And what we want to do is to make sure that we optimize the level of referrals to them so that way we can actually probably get rid of the blindness issue from all these diabetics and hypertensive people. That's, I think, is very good news. And so we have big support from the chief ophthalmologist at the CHUM, at the, excuse me, all of them. They're now very open to listening to what we do. One thing that's difficult for them to understand is this deep learning concept and all that. And I agree with that. I mean, the only reason why we use deep learning at the end of the day is to get a faster execution of the analysis of the images. But we use our traditional environment to actually train the algorithms before we train the deep learning to look at this. So we have a better way to explain to retina specialists, ophthalmologists, what is happening inside the image and why the software is going in a certain direction. But one thing is clear, it's not there to replace anybody in the food chain. It's just there to make, the bottom of the food chain, the primary care facilities, the endocrinologists take better care of their patients by actually doing the analysis earlier than too late.
So I think that might even lead me into my next question was regarding if you had the opportunity to get a message about your technology and what you're trying to achieve out to I think let's focus this on clinicians. So a global population of physicians or clinicians. What would you want them to know? Is it that this is not going to replace them?
Yeah.
Or do you want them to know, what is that you really want them to understand about your technology and the potential impact?
Yeah, I think the message is that this is not a threatening environment. So it's there to be able to actually screen more patients faster and better, making sure that the referrals are good to the specialist. That way they don't lose their time looking at this. And I think the way that we have built the technology is very easy to deploy in many different settings. Could be a software only, could be a managed environment, could be a mobile environment, to address, outskirts. I mean, there's a lot of ophthalmologists in cities and all that, but I can tell you in Chicoutimi or in Sept-Îles that you won't find any. So the technology is there to make it easy to screen more people and to give better referrals to the ophthalmologist.
I agree with everything. Like new technology sometimes is scary, right? And there's a bit of a curve, like for people to adapt and embrace it. So if you like, we have a pretty broad audience, composed of patients and doctors and eventually even investors that are looking for up and coming companies and technologies. Like, where people can know more about Diagnose, being a patient or a doctor.
Yeah. So we're a publicly trading company on the Toronto Stock Exchange. So our ticker is ADK. Andre, Dennis, and K for Kleenex. And we have, so you can visit our website at www.diagnose.ca or .com, or you can give me a call, and you go to our website. My number is all there, and I can discuss, either. I'm not a doctor. I'm a computer science fellow, so I'm more on a technical side. But over the last 7 years, I've learned a lot on the retina, and I can discuss as good as maybe not an ophthalmologist, but a junior ophthalmologist.
Fair enough. And you gave some information for anybody looking to invest. To check out the company is publicly traded. I think it's probably a good point for me to disclose, which you already are aware at this point, that I am currently an investor in the company as well. So just for full transparency and disclosure for people listening. So Andre, I'd like to just thank you for joining us today. It's certainly a pleasure to talk with you. The information I think is going to be helpful for clinicians, and for those who haven't heard of your company, hopefully they're taking you up on the offer to pick up the phone and call you or reach out through email or online. Yeah, excellent. Listen, thanks for taking the time to chat with us today. We certainly appreciate it.
You guys, and look, good luck. I support anything that's made in Quebec. That's for sure.
Excellent. Thanks so much.
Thank you, Andrea. Nice chatting with you.
Thanks.
And that concludes today's episode of the Broad Eye Podcast. If you enjoyed this episode, please be sure to subscribe on your favorite podcast platform. Of course, ratings and reviews are always welcome. And you can certainly share this episode with any of your colleagues or friends who might enjoy it. Thanks for listening.